the group D4, symmetry group of a square, there are 4 rotation, 4 reflection. You write down the 8 element in 2 line form, something like this. Usually we are not writing this thing because it will take a lot of space. So we usually write in the cycle notation. And now I pick a subgroup generated by mu1. How come I know mu1 times mu1 is E? You know where is mu1? mu1 is a reflection around this particular line. So mu1 multiplied 2 times, you get the identity. So this is the subgroup generated by mu1 actually. Let's try to figure out all the 4 distinct cosi here. Then we have figure out, is this a normal subgroup? H equal to E times mu1. Alright? Okay, now what other cosi I can talk about? Of course, one of the cosi is H already. Let's try another cosi. Let's try rho 1 on the left side, right? Rho 1, what is rho 1? Rho 1 is a rotation of 1 go to 2, 2 go to 3. This rotation 90 degrees this way, right? 1, 2, 3, 4, 2, 3, 4, 1. So rho 1, okay? Rho 1 is 1, 2, 3, 4, 2, 3, 4, 1. In terms of cycle notation, this is equal to, if you still don't know how to write a cycle notation, you just say 1 go to 2, then followed by 2 go to 3, 3 go to 4, then 4 go back to 1. Right? So in terms of cycle notation, this is actually rho 1 is 1 go to 2, 2 go to 3, 3 go to 4, 4 go back to 1. This is rho 1. Rho 1 times E. Of course, we expect rho 1 times E is rho 1. Mu 1 times mu 1. Rho 1 is 1, 2, 3, 4. What is mu 1? Mu 1 is, so if you write in cycle notation, 1 go to 2, 2 go to 1, 3 go to 4, 4 go to 3. And then you multiply them. How do you multiply? I'm going to figure out where the 1 go to. So, 1 go to 2 first. Move forward, look for 2. 2 go to where? 2 go to 3. There's no more 3 in front. Then you write down 1 eventually goes to 3. Next, I erase this again. I want to figure out where does 3 go to now. So from the back, I know 3 go to 4. Then I look for 4 in front. 4 go to where? 4 go back to 1. So, and there's no more 1 in front. Okay, 4 go to 1 and no more 1 in front. So 3 eventually go to where? 3 eventually go back to 1. So you can close. 2, start with at the back, 2 go to 1. Then look for 1 in front, 1 go to 2. So 2 eventually goes to 2. At the back, 3 go to 4. Now 4 go to 3, right? I'm going to figure out where the 4 go to. 4 go to 3. Then look for 3 in front. 3 go to 4. There's no more 4 in front, everybody, you know. 4 eventually goes to 4. So this is 1, 3. Whenever 2 stay put, 1, 4 stay put. What is that? That is rho 1, delta 1. Right? Reflection delta 1. Whatever in 4 stay in 4. Whatever in 2 stay in 2. Whatever in 4 stay in 4. Right? 1 and 3 interchange. So that is delta 1. So I find that this is delta 1. Okay, delta 1. the left coset, rho 1 times H is delta 1. Diagonal reflection. The diagonal reflection, delta 1 you can see here. Phase 2 and 4, 1 and 3 interchange. Now, the question I want to ask is this H a normal subgroup? How do you tell this is a normal subgroup? Now you check the right coset. Just now, I calculated left coset, right? Now, let's try to calculate the right coset. So I'm going to insert another one. So H is E mu 1. Just now, I have rho 1H is rho 1 delta 1. Alright? So now, let's look at H rho 1 on the right now, multiply on the right, right? So E times rho 1 we know is rho 1. E times rho 1 is rho 1. The only thing we don't know is mu 1 times rho 1. What is that? Right? Because now you multiply the right hand side now. So where is mu 1? Let's recall again. Mu 1 I have 1, 2, 3, 4, right? 1, 2, 3, 4. Like that. 1 go to 2, 3 go to 4. Right? Rho 1, I have 1, 2, 3, 4, one whole cycle. Okay, let's see. What is this thing? So I'm going to start with 1 again. So 1 goes to 2. And look for 2 now. 2 goes to where? 1. So 1 eventually goes to 1. So 1 is fixed now. Okay, now I want to figure out what happened to 2. Okay, everything from the back now. 2 goes to 3. Then look for 3 in front. 3 go to where? 3 go to 4. Is there any 4 in front? No more 4 in front already. So write down 2 go to 4. Okay, then I want to figure out where the 4 go to now. So I know 4 goes to 1. And then look for 1 again. In front, 1 go to 2. So eventually 4 goes to 2. So you close 4 go to 2. So by right you only have 3 left. 3 must go back to 3 now, nowhere to go. But you double check whether you have made any mistake or not. You try. Say I want to figure out here 3 go to 4, then 4 go back to 3 again. So eventually 3 go to 3. And what is that? 1 and 3 fixed, whatever and 2 go to 4. 1 and 3 fixed, whatever go to 4. Look at the diagram again. Whatever in 1 stay put, whatever in 3 stay put. 2 and 4 interchange. What is that? Is this reflection, this diagonal now? Not the earlier one, this one now. Reflection is here, right? You do this reflection in diagonal delta 2. Right? Whatever in 1 and 3 fixed, 2 and 4 interchange. So this is actually delta 2. Reflection diagonal delta 2. So this is actually delta 2. So look at this. They are not the same now. The left coset is not the same as the right coset. So this H is a subgroup of G, but it's not a normal subgroup. Okay? A normal subgroup, every coset, left coset and right coset must be equal. So this is not a normal subgroup of G. Subgroup of D4. So If this is not a normal subgroup at default, what does that mean? That means that you multiply a coset with another coset, you are going to get into trouble. That means your left coset, if one left coset AH times BH, what do you get? This thing is no longer, may not be a coset anymore. No guarantee already. Okay? May not be a coset. If you're trying to do this, you'll find that after so you have the coset, let's say AH and BH, and you know H is not normal already. You multiply them up, you may not get a coset. No. What does it multiply? Okay, let's try to figure out what does it multiply mean. Okay, multiplication means what? Maybe should talk about how you multiply coset. What do you actually mean by multiplication? Okay, the meaning of multiplication means this. Suppose you have a left coset f of h. Let's say you got 3 elements, say x1, x2, x3. And then another left coset y of h, let's say y1, y2, y3. So we know that all the cosets have same element. So when you do xh times yh, trying to multiply coset, what do you get actually? You're trying to look at all the possible multiplication. It means that x1 times y1, x1 times y2, x1 times y3, x2 times y1, x2 times y2, x2 times y3, x3 times y1, x3 times y2, x3 times y3. This is what they mean. Multiplying coset. This is what they mean. What we know is this. For h that is not normal, when you multiply the coset, you will not get back another coset. This is an example to show that not every subgroup are normal. Okay? When the subgroup are not normal, when you multiply coset, you may not get another coset. And how do you multiply coset? This is how you multiply coset.